Hey guys, it's Darren here from Global Garage. Today we're going to run through a RGB mod for a Master System 2. We'll put on the LED, we'll do a controller pause mod, we'll do the Master System 1 socket output, and which gives this RGB. So first things first is to turn it over and take out all the screws. Flip it over and there's just 5 screws, each of the corners and one in the middle there. Take them out and flip it back over. So all the screws out, just lift off the case and you'll see plenty of dirt and grime and all sorts of filth. So first job is to fully disassemble and clean the unit and give it a test before you go any further. Some of these old consoles don't work, so before you spend time and money modifying it, you want to make sure it actually works. So let's pull out the screws on the shield here. It's just all these silver screws around the edge, so just right around the edge. Take the shield out, we'll take the screws out of the motherboard, lift that out, and we'll just give it a good clean case and base, and we'll come back to that point there before we start anything. When taking out the screws, just pay particular attention to these two down here. So this is the voltage regulator, so the screw that holds that in, and the screw just above it, which holds the heat shield, the RF shield. It's sort of in place. They're slightly different screws to the other ones on the corners and up in here, so pay attention to them, put them in a separate. So the heat shield will now just lift straight out like that. Put that aside. I've got a few of those, so I might actually use a cleaner one when we reassemble it. Now, so don't forget the screws on the side of the cartridge slot. Then the whole thing will just lift out. So let's go ahead and do that. Okay, so once the screws are out, you can just gently hold the middle here and just lift the whole board out. It'll just come right out. You know, underneath the board's pretty clean on this one. And that's the lower RF shield, so we'll take that out in a second. So to clean the board, I just like to grab a simple utility paintbrush, nice and soft and dry, and just dust it down. You can use a can of compressed air or just a simple brush. Okay, so I've washed the plastic and it's time to put it all back together. It's come up really well, it's nice and clean, no more dust and junk all over it. I've just put the tray back in and we're ready to cut some holes and mount some connectors and switches. Okay, so what we're gonna do now is just do a quick test fit and just work out where we're gonna mount the switches and connectors and so forth. So just put the board back in. We've got a socket here. This is a Master System 1 style socket. It's the DIN socket, which you can pick up from JCar in Australia. It's got the correct amount of pins. So we've got one. So it's ground up the end here. 1, 2, 3, 4, 5, 6, 7, and 8. So we'll use that in a minute. And I've got a simple toggle switch here. Just so that's going to be the 50-60 Hertz switch. I'm going to mount that over in the side, I think over here. I'm going to mount the connector on the back panel, probably about here. So the wires will feed in, go straight to the chip, pull the RGB. Okay, so to mount the RGB circuits, which is a few capacitors and resistors, we're going to need to mount it on a board, and we'll cut this board down to size, but you can pick up this sort of board at JCar as well. I think it's called Vero strip board. You can get it with either traces on it or without. I just use the simple board without the traces, just a simple plastic board, and I'll cut it down to size once I've mounted everything. Okay, so let's cut some holes to mount the connectors. We'll put the multi-out connector up the back here and the switch on the side, as we said. So the tool I used to do that, got this little packet here of step down drill bits, little kind of like Christmas tree drill bits. You can pick these up at any hardware store. Here in Australia we have a store called Bunnings. They sell these for maybe like $10 a packet. If you can look closely, I'm not sure if that's going to focus well. You can see the sizes of each hole there in millimeters. We're going to be using about the 14 and 20 to cut these holes for these. So I'll just go ahead and do that now. Okay, so I've just stepped outside, got the drill bit mounted in the drill, AEG, cordless. These things are unreal. If you ever want a cordless drill, this thing's probably the best. You can get the 4 milliamp hour batteries. They do all sorts of different things. I had that on hammer the other day, so let me just put that back to basic drill. And we can cut some holes. Alright, let's do it. So there's the first hole drilled. That takes us, so we've stepped it up to about there. That was the 16mm hole for the socket, so let's mount that. That'll go in there. We'll drill 2 little holes next to it for the screws. That'll bolt in. Now let's do the switch. The switch will sit on the side here, about here. So we've just got to find a position that's not going to get in the way of this strip, and that should be fine. Okay, so I've cut the hole. It's pretty big, this one. It needs to be. Now we've used the whole width of the drill bit here, which is right up to 20mm. We use the whole lot because this is quite a chunky switch. Now, you can obviously run a much smaller switch or a pick, and you can do switchless mod. I kind of like it old school with the master system, so I'll just put this switch in. These little locking tabs here help it, once you slot it in, they lock it in place. So you just like pressure will hold it. But that little bit of plastic there sometimes gets in the way. You've just got to force it in to that little slot back there. So I'll show you what I mean by that. Let me just try and push this in. Okay, so I've just pushed that in. It's a little bit crooked, so then we'll just grab hold of the pins here and just rotate it a little bit like that and get it nice and straight so it fits under that plastic well. It's generally quite a nice fit. Yeah, it fits really well. From the inside you can see that it doesn't quite touch the post. It's very close. That's how I like to mount it. So the connector will come in like that, switch is there, and you've got plastic and shavings everywhere, so we'll just give that a quick clean up and we'll go back inside. Okay, so we're back inside. I just wanted to quickly show you these holes. Once you've drilled them, there's fragments of plastic and things all over them, so just give them a rub down. You can even grab a small file if you really wanted to. Just make sure they're really smooth and clean before you mount the switches, otherwise they won't sit properly. So I'll just mount them and we'll continue on. Okay, so there's that switch mounted. It's a really nice tight fit on that side, and this one's also ready to go. It's plenty of clearance off the board, so you're not going to short out down in here. So, okay, so our next step is to pull this back out and solder on some wires. I'll show you where the wires go on the board, and so we can measure some lengths and get that right. Now I haven't done one of these for a while, so I've got my cheat sheets here in front of me. I'll just give you a quick look. So the multi-out on the back of a master system has those pins and those signals on the pins. It's a Genesis 1 or Mega Drive 1, it's the same thing. So this is how we're going to wire it up. Pin 1, composite, ground, mono. Now it's only mono audio with master systems, no stereo, just the single wire. Green, 5 volts, composite sync, red and blue. So there's the pin order and corresponds to the pin order right here. Keep in mind that's looking at the socket that direction, so like that. So to wire up, you've got to then wire up to the back. So just make sure you sort of get that right and line up the correct pin numbers, sort of in a flipped orientation to the back here. Okay. Here's another cheat sheet. Here's the pinouts of the video encoder. It's a CXA 1145, as it says up there. And if you look on the motherboard, it's the one at the back here. So The light's a bit rubbish, but you can probably see that. Sony CX-A1145P, made in Japan. So we're going to be taking the RGB and composite off the back side here. We'll get to that in a minute. And let me just show you what we've got. So if we turn it this way, that's where I was pointing. You'll see that we've got red out, green out, blue out, composite video out. So we need on that side. Those other signals aren't required today. So there's, RGB composite video. It's ground over here if you needed it. There's some other signals here. There's an audio out there. Composite sync out. We'll come back to that one a little bit later. But that's basically the output diagram. Now, I think you can get a copy of this off the internet. It's a Sony document. And just search on that number right there. Okay, here's another cheat sheet of the CX-A1145. This is pretty much the wiring diagram we're going with. So once we take our pinouts and our RGB lines, we're going to just run some resistors and some capacitors in series, and that'll form our output. So the numbers down here, such as 24, 23, they're the pin numbers on the chip I showed you before, the Sony chip on the board. That's where we solder them to, and that's where we take the output. We've got a ground, you can take off 24, or to be honest, I take ground off the voltage regulator. RGB, they're very straightforward, just 75 ohm resistors to the positive side of the capacitor, 220 microfarad, and just a simple 10 or a 16 volt capacitor is fine, nothing too fancy. And then they'll go out to our socket. These pins aren't required, that's S-video. Similar sort of output if you wanted to do it, and they're the pins to take it from. But I never run S-video, not with RGB, you don't need it. Composite video, was pin 20, same output. And audio, it's recommended to take it off a different chip, pin 15. You can, however, take it off the same chip, but it's arguably a better signal coming off the that one there. So Sega 315, 5246. Let's just have a look where that one is. Yeah, so that's the chip there. Okay, so I'm just about to start soldering on some wires to our multi-out connector. Down here, we've got our little cheat sheet in front of us, so we know what goes where. Before I get started, from experience, if you put too much heat on these pins, it'll melt the plastic. So grab your RGB SCART cable that you're about to use when this is all done, plug it in, and it sort of just helps to suck the heat away. So just like that, just put the actual cable in, and as you heat the tips up, the heat will run down the wire. Just keep the plastic from melting. So it's just a little tip I've picked up over doing this a few times. Okay, so I've just started to put the wires on. That's the ground, and the funny thing with this circuit is ground's on pin 2 down in the middle. It's also up on that top case shield connector. I'm not sure if you can see, but that one right there, like that top. So I just make a little loop wire, which I'll connect up at the very end, and I'll come back around at the top. What I wanted to point out right now, though, is as you look at the circuits, you've got, we'll do pin 4 next, which is green, so we'll put a green wire on. You've got to remember that this is flipped, so in the diagram, pin 4 is off to the left, but when you look in the back of the connector, it's going to be on the right. So it's this one right here, and that one there. So just keep that in mind, that it's kind of opposite when you look at it. I work at the bottom and we work up just like that. That one's pin 4, and that one will be pin 5. So 4 and 5, opposite, to show you how you see them there. Okay, so we've mounted the socket, we've soldered our wires, and I've put some little bolts in to hold it in place. So that's all nice and tidy now. Really clean fit, and there's no shortings, not touching the board, not touching the case. Just definitely check that. Make sure you get nice clearance there, and you should be fine. Okay, so we've finished the socket, we've soldered up the wires, and we've just run the the red, green and blue and the composite video to a little board made up. So I've cut the board to size as well. So mounted the capacitors, 220 microfarads, the negative side, which is with the stripe facing out, that's the output that goes to the socket. Positive side joins to the resistor, just joins underneath. And we feed the signals in off the chip down there into the resistor. So the whole idea is it's going to sit somewhere about there on an angle. Once we put it all back together, the feed comes in off the chip into the bottom, into the resistors, out through the capacitor, out there, and the wires we've got left over are just voltage, some audio and some ground and so forth. So I'll keep working on this and I'll show you the next step. Okay, so I'm just going to take the board out quickly and flip it over. What we need to do next step is run 2 wires off the controller 1 port, which is this one, off some pins here for the pause mod. That works by basically taking the left and right signals at the same time, running them through a little logic gate and pressing pause for us basically. So before we can screw the board back down, we just need to solder to the underneath of the board, and then we can start screwing the board back down and working on the top side. So let me just put those wires in place and I'll show you which pins to use. Okay, so I've just soldered the wires on. They're a little bit big, these two, but they come as a molded pair, so I've just used these. They could be a lot smaller, and it's probably easier to work with smaller wires. In fact, it's probably easier to work with smaller wires on the whole project, but this is all I've got today, so that will do. Pins to use are these two here. So controller port 1, which is on the left. If you really wanted to, you could also do this mod to the second controller port, but I don't see the point. Just one controller can control the pause function. So bottom row of pins, so there's a top row and a bottom row, and from the right hand side it's pins 2 and 3 from the right. Just put a wire on each one, it doesn't matter which way they go, and we'll connect up the other end in a minute. Okay, so I've just flipped the board back over, and here's our wire coming out from underneath. So it's basically connected up to this controller port right here. It goes just under the board and comes out here. Now, this RF shielding on the base tray here, I just fold the lip down flat, just to make a little bit more room for the wire to come out underneath. It's not critical, but yeah, I think it just helps. I avoid cutting the shield, top and bottom, because it gets really sharp, and you can do this mod without cutting it. You don't even really need to refit it, but it's up to you. You know, you don't really need the RF box whatsoever. If you really want to, you can cut the 3 pins down in here. These 3 pins underneath just give it voltage. So if you're never going to use RF again and you're just going to use RGB or composite, go ahead and snip those pins, save some power, and you can pretty much do away with the RF shielding, because the whole purpose of RF shielding is to shield from this. So if you disconnect it, you no longer need the shield. So that's up to you. So what we need to do is we need to connect these two outputs of the wire to the input of the 4071, which is a OR gate. I'll explain that in a minute. Now the input pins are here on this side, so the notch, I've got the notch facing down just to make it easier to work with. Input pins are 1 and 2, so from the bottom here, input 1, input 2, which is our grey wire, and the 3rd pin will be the output, which we'll come back to in a minute. Everything else we can pretty much leave, but the chip does need voltage and ground, so just simply voltage is down here on the opposite side. That's opposite the notch, and ground is the direct opposite, so directly opposite the chip. Voltage is always the other end, so the very end, the very back pin. Basically the output's going to go over here to the pause switch, so we'll wire that up and I'll show you that in more detail. Down here, you can just type in 4071 into Google and do an image search. We'll come up with this right here. So the top left, 1 and 2, they're the input sources. Pin 3 is the output. So we're going to connect our controller port to pins 1 and 2. The output will go to the pause button. The others we're not going to use except for the voltage, which is top right, the VDD up there, and the ground, so pin 7. So it's pretty much top right hand corner voltage, bottom left ground, and the top left 3 input and output. So the chip's now in place and I've soldered it in, notched down. Input pins 1 and 2 are now connected off the grey wire, and output pin 3 I've soldered in place. Just put that back. And I've used a white wire, you can use any colour you like. And output pin 3 I've just run along here to the pause switch, and it goes on the far side. So that top left, if you're looking at it from this position. We'll tidy this up a bit later, hot glue it down probably. But I just like to route it, under some easy sort of loops that you can find in the circuitry. While we're messing around with running wires along this side of the board, we may as well run the 50-60 Hertz switching wire off this Sega chip right here. We need to lift the 4th pin from the right. So the 64, you get the longer pins that come out a bit further. So longer pins we're interested in, and it's the 4th one along. So it's that one right there. So count from the right in, the 4th pin, and that gets soldered down to the board. So we'll just get some cutters and we'll just cut it at the end there, lift the pin, and that's where we need to solder our trigger wire to. I'm just going to try and film this and show you how to actually do it with some cutters. So these are some little side cutters. Well, actually they're quite big. Good investment is to buy yourself a really good set of little cutters to do delicate work. These are okay, Duretex from JCar, but you can get much better, smaller ones. So we'll just count again. 1, 2, 3, 4, 4th pin, and we simply just cut that like that. So just cut that pin, and I just slightly lift it, and then you can see that it's separated off the chip, not touching the board anymore, and we're free to solder a wire onto that. Okay, so that's cut and soldered. Just run a wire off that pin, just make sure, absolutely sure nothing's touching any other pins or the board. I've also tucked it under that component with the white wire off the 4071 chip, and I'm going to route that all the way up to our switch over here, the center pin. Okay, so let's run our RGB lines off the chip. Using a massive screwdriver here. It's not the best pointing tool, but it'll be okay. So the Sony CX-A1145P, nearly all Master System 2s have got this chip, so you should be fine. If you don't have this exact chip, which is right next to the RF and in between the Z80 processor, you'll have to look up the pinouts. But this one's quite simple. So looking at it from the very top, and the notches at the left, the top pin up here is ground. Then you've got red, green, blue, and compass and video. So we're basically dealing with these pins right here. The very top ground one, we're not going to worry about. We'll take ground from the voltage regulator a bit later. But we are interested in the red, green, blue, and composite. Now you can solder it directly to the chip here, which I'm going to do, or you can pull the motherboard back out and solder it to the underneath, and route your wires maybe out here. Fold that bit of metal down, and you could route them under the board and around the back, and into your board. I'm just going to run them straight across here, curve the wires around it into the board, keeping it well clear of the cartridge slot. So let's do that now. I'll run the wires, cut them to size, and I'll solder them to my board. Okay. Actually, and just before I run the wires, it is a little bit difficult to solder to the pins of the chip. They're quite shiny, so very carefully you can scratch the pins to make it easier for the solder to stick. And on this particular job, probably use a leaded solder or some flux to make it really easy to solder. You never want to put too much heat onto the pins because it can damage the chip. So I might use these needle nose pliers to scratch the pins a little bit very carefully, being very careful not to scratch and damage the board. You can also use a little nail file or something like that. Okay. put a little bit of this on. It's a little bit of a flux pen, so I just scratched up the pins and just put a bit of this on, just like that. Scratch it up with the metal pliers and then put on some flux. Just makes the whole soldering job a lot easier. Okay, so I've tidied up the wiring a little bit. I've soldered on the red, green, blue and composite video wires on the Sony chip. I've also put on, off pin 11, I've run the composite sync wire, and that goes straight to the output socket. I still haven't done the audio wire, that's that white one sitting there, I'll do that in a minute. I've also tidied up the power and ground off the chip here, so I've just run the power and ground up to the switch. So ultimately the 50-60 Hz switch has 5 volts and ground sitting on it the whole time. That's what it has to do to switch the 50-60 Hz mod down here. So we may as well just tap off that. So we'll take, this red lead here is the voltage going to the chip, and I've also run a ground over to this side here. The ground also loops over to the ground socket, and ground runs all the way back to the voltage regulator. It's a bit of overkill. I like to run dedicated ground to the common pin of the regulator. And also what I'm about to do is run a 5 volts output off the output pin of the regulator, which is going to be right there. You don't have to. You can actually run ground off anywhere where there's ground, or anywhere you can find a clean ground or 5 volt signal. I just like to run. While I've zoomed in, I'll just show you quickly how this regulator works. So it's a 7805. 9 or 10 volts is fed in via the power connector up here. Comes in on that leftmost pin there. If you look underneath, it's actually labelled input. It's actually input. That means that means 9 or 10 volts. Common is ground, and output, the O, is 5 volts. So basically 10 volts comes in, the chip regulates it to a nice steady clean 5 volts and outputs it on this pin here, and the middle is just ground. So this is the best place to take your 5 volts and ground from, I think, but you can go ahead and take it wherever you like. And you might be wondering why I've got this extra ground wire coming off the common pin. I'm also going to do the same with the output pin. I'm going to do that here as well. That's in preparation for the LED. So the LED is going to sit, around here somewhere, and we need some voltage and ground for that LED. So I'm just sort of prepared that by running the extra feeds now. So off the socket, one of the pins is a +5 volts. It was the yellow wire that I used here, coming from right down the bottom there. That can take 5 volts from anywhere on the board. I like to take it off the switch here because I've already got 5 volts handy, but the only thing I do is I just put a 100 ohm resistor right there in series with that wire, and I'll slide that heat shield right here over that resistor and just tidy that up once we're done. Okay, so I've tidied up a few wires. I've finished running the power to the voltage regulator. So now I've got ground and 5 volts coming off the regulator, nice and clean signal. Just routed them back over here. So I've got just terminating at the switch and feeding voltage when necessary. The chip here is done, that's all tidy. These 2 wires are just ready for the LED. I'll put them on shortly. I just ran the audio wire, so one of the final wires coming off the socket is the white audio. There's a couple of ways to do this. You can actually run it straight off the Sony chip up here, or you can run it off pin 15 of this big Sega chip. Unfortunately, pin 15 is pretty hard to get to. Pin 1 here, that 24 you see is off this chip here, so don't worry about that. Pin 1 there, pin 32 up there, pin 33, pin 64. So it just walks around that way. So you'd start here with pin 1, that really short one. 1, 2, 3, 4, 6, 8, 10, 12, 14, and then 15 is a little one in there. And you could, probably easy to flip the board over and solder to the underside of the board, but I've just got a 10 microfarad capacitor here. It's 25 volt one. It's too large, but it doesn't really matter. It'll work fine. 10 microfarad is what's recommended to come straight off the Sega chip here. Pin 15, just put a bit of solder on that pin, bent the leg up to make it work. Don't know if I can get a good angle on that, but yeah, it's not too bad there. You can see I've soldered that on. The positive side goes to the chip, the negative side with the stripe comes out and goes to the socket. So the socket's pretty much wired up now. We've got 5 volts through a 100 ohm resistor. We've got ground. We've got the RGB going over to the chip. We've got the composite going to the chip. The composite sync, this orange wire coming off pin 11. We've got our board all put together. So our board's pretty tidy. Got our RGB capacitors and resistors. We've got our pause OR gate ready to go. That's all wired up. That'll just sit there on an angle. We'll hot glue that into place. Pretty much ready to go. Look, it's a little bit of a mess, but once this is tidied up, it all makes sense. So the final thing is to probably give it a quick test now. I'll just make sure these wires are covered up so they don't short anything out. I'll give it a test and we'll flip the switch and we'll see if we get video output. We'll see if we can toggle the frequency and make sure everything works at this stage before we go any further. So let's do that. Right, I tested it out fine on the TV, everything is working. I did have a little sort of composite sync, C-sync sort of issue where the picture was sort of ghosted. I couldn't quite work out what was going on. I thought the problem was coming from the C-sync pin 11 here, but that seemed to be getting through perfectly. There was no problems there. What it turned out to be, and if you ever get some sort of ghosting weird signaling, off this connector here where you run, we run a 5 volt feed to the SCART connector basically. I had that running through a 100 ohm resistor as per the schematic diagram I've had. Now, I always run it through 100 ohm to step it down a little bit, but I think what's happened on this case is at the other end of the SCART cable, there's another resistor that bridges pins, I think 8 to 15, which is used to control how SCART converts, or used to control how SCART selects between composite video and RGB. And I think what was going on, the voltage wasn't quite right across those pins, and it was stuck in composite mode and sort of displaying half composite, half RGB. It was quite odd. So I ended up taking that resistor off that 5 volt line. So it's straight 5 volts straight to the connector, straight out to the SCART plug, and everything's fine. That worked perfectly. So I think that's what's going on there, but that's why you test it at this stage. Before you tidy everything up completely, fully test it, and just iron out any bugs like that. The audio sounds really clean with the 10 microfarad cap. So pin 15 off the Sega chip, 10 microfarad, positive light, positive side to the chip, negative with the stripe to the audio feed. That sounds mint, and I think it actually sounds better than taking the audio off the chip up here. Here nor there, but alright, so the last thing we need to do is put our LED on. So we've already got the wires ready to go, and tidy this up a little bit, and then get onto the controller. Basically open up the controller, put in the micro switch, put in the 2 resistors, put it back together and plug it all in and test it live on the TV. So that's what we're going to do next. I've just temporarily connected the wires to the LED with a 100 ohm resistor. Always chuck 100 ohm on the positive lead, just stops the LED from blowing. It can run off direct feed, but it's better to use a resistor just to drop that down a little bit. Alright, so what we're going to do is we're going to drill a hole in the case. Okay, and I've mounted that now. I just decided to mount it in the front. It's I just checked with the customer, and that's what they've asked for. So it's in the front. That's a nice deep blue when it's lit up. Just temporarily put in there. I'll fix up that heat shield in a minute. Just keeps them separate. There is something to note. There is the 100 ohm resistors just here in this 5-volt line, and they're both off the regulator. So that's the LED mod complete. Right, so the whole thing's pretty much done now. It's a matter of just tidying up all the cabling and putting the case back together. So I'll hold the mods there, finish off the controller quickly, and then we'll test the whole thing out. Okay, so the modification to the controller is really simple. We're going to put a pause button right here, just where your thumb would naturally sit. You're playing, pause. So to do that, we just have to do a bit of trickery to the circuitry and just sort of trick the console into thinking we've pushed the pause button. So that IC we installed earlier, the 4071 OR gate, that is the logic behind it. That's wired up to the pause switch, and it's waiting for the right inputs. What we're basically going to do is trick it into thinking we're pushing left and right at the same time, which is an impossible signal, or up and down, it doesn't really matter, and that would trigger the pause action. So I'll explain it in a minute. Let's just open this up. We'll give it a clean while we're here, and we'll install the parts. So we flip it over. Yeah, it's pretty dirty, this one. Flip it over. I'll take these 6 screws out of the back, and I'll show you what's inside. Right, so the back's off. Really simple just to pull that apart. There's two boards in here just linked together, and they haven't been opened in a long time. They get a bit stuck, as that one was a little bit stuck. And what's basically here? There's no chips or anything. It's just pure old school sort of wiring and some contact pads. These are the contact pads for the buttons, and these are the contact pads for the D-pad. So while we're here, let's just do a quick clean. So you push the button. This is a little rubber membrane, and that black center, that's conductive. So that actually conducts electricity. And as it pushes against the contact pads, it joins these little traces together. So effectively, you're joining these two lines together by pushing down on the button. So as you can see, they're pretty dirty. This one did work, but we'll give it a clean while we're here. And they all work similar ways. So you're effectively joining ground to one of the wire outputs. So let's give it a clean, and then we'll solder in the components. Okay, so I've given them a good clean. I've pulled all the parts out. I've cleaned the pads, cleaned the contacts. I'll give the plastic a clean in a second. But I just wanted to quickly show, this is the best stuff for cleaning electronics. It's called CRC Contact Cleaner, Precision Electronic Cleaning Solvent. Leaves no residue, low in toxicity, and blah blah blah. These excellent for cleaning contacts. So this is a massive can. This is like a 525 ml can. So I basically just I've sprayed on all the contact surfaces, and then get a rag and basically wipe them down and just really clean them really well. I've already done this and given them a really good clean, so they're pretty good. They're all good to go, I think. So we'll reassemble that in a sec. Now, in preparation for the components we're putting in, before I wash this, we need to get the old drill out again. So here comes the drill, and what we're effectively doing is we're going to drill a hole right here and mount a little tiny micro switch. I'm going to mount it right in there, and you pretty much drill right where that round plastic mark is. It's just for the tip of the micro switch to poke through. It's really easy to work out where to drill once you have the switch in your hand. Let me just grab that switch and I'll show you. Okay, so this is the switch. You can also pick these up for J-car. Just micro, like really tiny, a little click, and that's all we need. So we're effectively going to connect up some of these legs to basically short the D-pad left and right at the same time. Doesn't hurt the controller, just sends a signal, a grounding signal actually, down to the OR gate. So if we just sit that in about there, that's where it's going to go. And we're going to measure the output, measure that round button, and that's the size drill bit you'll need, and go ahead and drill the hole. The only way to secure that is with hot glue, so I'll go ahead and do all that and I'll show you the finished product. Right, so here is the finished product. I've hot glued the micro switch into place. I haven't really cleaned it up properly yet, but there it is there. The pins are sticking up ready to solder to, and we look on the other side, we have the button ready to go. So that is excellent. Alright, so let me show you how to put this back together and how to solder it in place. So we're going to need the 27K resistors, which are over here. Just grab a packet like that, no big deal at all. Just going to need 2 of those, and that's actually it. That's all we need. So what we do, first of all, you've got to identify which way is left and right. So these pads here, if we flip that over, see the wires attached. I just got to work out where they go. So left goes up there to orange, and right goes to yellow. So orange and yellow are our solder pads we need to worry about, and we're just connecting that to ground, and ground is that solder link down there. So this whole middle section. So effectively what we're going to do is join one resistor off one line, so one off orange, one off yellow, to the switch, which is in the body, and then from the switch back to ground. So effectively, when you push the micro switch, you're shorting both left and right at the same time to ground. And these controllers work sort of opposite to what you think. The pads are held high, so they're plus 5 volts high logic the whole time, and when you push it, it grounds one pad to ground, sends a it sends a ground signal to the motherboard, and that's what activates the movement, the D-pad or the buttons. So they're all held at 5 volts, so we just need to short them to ground to send a trigger. So let's do that. Okay, so that's all soldered up. Now, it definitely is a little bit tricky, but effectively what we've got, let me see if I can show you, we've got one resistor coming off each of the pads underneath, so just make sure it's left and right, and you can trace those back. You know, you got the left and right there, one each. Now those resistors join up together, so you join them together onto one pin. So if you look right down in there, both are coming down to one pin of the micro switch, and the other pin of the micro switch, if you can look really closely, I've run a little black trace wire up to the ground pad. So that's effectively it. So ground pads on the underneath of this little wire link, you can really run that ground wire anywhere you like, it doesn't matter. So one resistor off each of the left and rights, so one off orange, one off yellow, joined down together to one pin of the switch, the other pin of the switch back to ground. That's it. If you're wondering which pins on the micro switch are active and which ones aren't, I'll just grab another spare switch. You can use a multimeter, I always forget, so I just did that actually before. It's the two that are closest together, so these two here, or those two on the far side. The ones that are furthest apart are not connected, so just grab a multimeter, do a quick continuity check, and that should be pretty easy. Right, so this is all done. We've cleaned it. We'll now clean the plastic. We'll put the pads back in, and we'll give it a test. So that's all back together. I've just put one screw in just to hold it, to test it out, because the last thing you want to do is put it all back together and find you've got to resolder a wire. So just make sure everything feels okay. Buttons are all responsive, and that's got movement in it. Sometimes be careful, if you put too much hot glue in behind that, it can actually ruin the button and stick it. So just make sure that still works. And then it's time to basically plug the whole thing in and give it a test before we seal it back up. Okay, so let's test it out. Okay, so here we go. We've got it plugged in. Now, apologies for this messy space. My testing area is out of action at the moment. but just borrowed the power from Master System 1 underneath there, plugged in an RGB SCART cable. Nothing's really glued down yet, but it should all work. I've got the controller plugged in. Got the controller here in front of me. I still haven't cleaned the plastic, just very basically put this together. We've got SCART running into a little switch box, and then down into an upscaler down there, and then into a Samsung TV. So let's do the honors and flick the switch, which is down here. There we go. So our LED works, and we've got picture, so that's all good. Looks good. Let me just check a few things on the TV remote. Picture size 4:3. Yeah, so let's go 4:3, and just quickly check the upscaler. Where's the buttons? There's the buttons. There they are. SCART RGB PAL 12A/1024. That's enough for now. It's actually quite a nice resolution. So I'll leave that where it is. Okay, let's grab the controller. So controller in my hand. Push start. There we go, that's better. So when you clean it, it's far more responsive. Left and right work pretty well. There you go, that's all good. So let me just go. Playing one hand, it's pretty hard actually. Where's the ring? It's in here, is it? Where's the punch button? There's the ring. Grab the ring. And what you're going to want to do is push pause, which is now on the controller. Yeah. Select your ring, unpause, and you can shoot fireballs. That is unreal. So let's go and shoot. Oh, I don't know if I can jump here. There we go. One hand, jump and shoot. Uh-oh. Close. Jump and shoot. Boom. One hand. All right. So the last thing to test is the 50 to 60 hertz switch. If we just check the upscaler quickly, reach in and push the button, and we get a prompt. RGB SCART PAL. Okay, so knowing that, let's flick the big toggle switch down here. In the background, you can hear that changing. It takes about a second. Yeah, it takes about a second or so for the upscaler to pick up the change. Let me just reach back there. Okay, so there you go. NTSC. So it's 60 hertz. Music's fast. If I pick up the controller, yeah, he runs a lot faster as well. So the whole game speed's faster, as it should be. There he is. So he's flying. So where are we? Let's push our pause button quickly. Get our ring and shoot this dude in the face. Boom. So I just want to quickly explain how the logic chip works with the pause mod. So it's an OR gate. Now I'll show the truth table for that on the screen in a second. But what we're aiming to achieve is this pause switch lives in it's basically 5 volts on that pin that we've connected to, and as you push it to trigger the pause, it shorts to ground. Pretty straightforward, right? So what we need to do is this wire we've got coming in, we need to short this wire to ground to simulate the button, tricks the board into pausing. So our trigger wire is 5 volts the whole time coming out of this chip. We need to trigger a low state. So we know that the controller ports coming in are also at a high state, and as you push left or right, those pins go from logic, let's call it logic 1, down to a 0. So how it works is you can push left or right, and you'll still get a 1 output. So you'll still get a high voltage output on that line. So in effect, this line is 5 volts all the time, and it's only when you push both buttons at the same time, left and right, which is impossible through the controller until we put that switch in, that you get a 0 state. Now, let me just put up the truth table. So as you can see, 2 input OR gate, you got B column, A column, and Q column. So the A and B doesn't matter which way they go really, but so if you look at the bottom first, the bottom row is all ones. You've got left and right both high voltage, which means they're unpressed. So if either left or right is unpressed, the output's 1. Okay. If left is pushed, and right's not, the output's still 1. If right is pushed and left's not, it's still 1. So you can see that 3 out of the 4 states do not affect the output. We want the output to be 1. We want it to be high 5 volts the whole time. It's only that very top row where you see 0 in B, A, and Q that it means if left and right are pushed at the same time and held low, which we do with the 2 resistors and the logic switch, and we get a nice clean output 0 coming down that line, that's a ground, triggers the switch. So there you go. It's a little bit tricky, but you know, when I first looked at it, I didn't understand it, and then I looked at the truth table and it all makes sense. So it seems weird to use an OR gate, one or the other, because you're not, you know, when you're pushing both buttons together, it's like an AND, but the truth table is the only way to work these things out. So yeah, that's my little explanation for that. Hope that was helpful. Alright guys, that's it. So this mod's done. So I'll do a final tidy up of these wires. I'll make this a lot neater, and I'll put the cover back on, put some plastic conditioning sort of rejuvenation stuff on it, make it look nice, and I'll ship that out. So thanks for watching.